So today we will see Leetcode 1081, the smallest subsequence of distinct characters. So given a string, return the lexicographically smallest subsequence. Now what do you mean by a subsequence? So if I say C A C, is this a subsequence of this string? Yes. Why? Because when I remove these characters, I can get this string. So yes, this is a subsequence. Now you cannot change the order of these characters. Okay, so this is a subsequence. Now what do you mean by lexicographically smallest? If I take this string A, B, C, this is lexicographically smaller. Why? Because when I traverse, I get here B, here A is coming before B in alphabetical order, therefore this is smaller. This is lexicographically smaller. So this is lexicographically smaller subsequence of S such that it contains all distinct characters of S exactly once. So this is the question. Now I will explain the algorithm. How are we gonna solve this question? So whenever I get a string, I'll firstly take whatever I get. This is the answer string. I'll take B. Okay. Then I come to C. So when I get C, I'll firstly check if this character C lexicographically smaller than B. Is it? No. C is not lexicographically smaller than B. Therefore, I simply append C. Okay. Now when I get A, I'll check. Is A lexicographically smaller than C? Yes, A is smaller than C. So what I'll do, and yes, again I'll check. Is C repeating afterwards? Is C available anywhere ahead in the string? If it's available, then I can simply remove C. Why? Because since we want all distinct characters must be present. So therefore we cannot directly remove C. After checking is A lexicographically smaller than C, we cannot directly remove C because we want all distinct characters. Therefore, after checking if is A lexicographically smaller and is C available ahead anywhere in the string, if both the conditions are true, I'll remove C. Okay, I removed C. Now for B, is B lexicographically higher? Yes. And is B available ahead? Yes. So therefore I'll remove B2. Now I'll add A. Now comes B. Is B lexicographically smaller than A? No. I'll append B. Is C lexicographically smaller than B? No. Therefore, sorry. Is C lexicographically smaller than B? Okay, no. C is not lexicographically smaller, therefore I simply append C. So this is the answer. Now, if you understood the algorithm, you can try it on yourself, or I'll directly jump onto the code. So, for the second condition, to check if the character exists ahead anywhere in the string, I'll make this array. Okay, and I'll fill this array with the last index, with the index that is present. Suppose if I take A, B, C, and I'll store in this array last. For the B part, I'll store the index of B, this B, not this B. For this purpose, I am using this last array, and for checking if the character is repeated or not, I'll use an hash set and a stack for creating my string. Now this is the main loop. So if the hash set already has that character, I'll simply skip the iteration, and this is the part where I said if the character is lexicographically higher, then and if it exists ahead anywhere in the string, I'll simply pop that character and remove it from the hash set. If not, I'll break the loop and I'll add the every character in the hash in the stack and hash set, and after that I will declare a string builder, and while st is empty I'll simply append all the characters from the stack to the answer string builder, and I'll reverse the string builder because it's in the reverse order, and then I'll convert it into a string and return. The time complexity of this code is big of n, unless in worst case it might get turned to n square, but it's very rare. The overall time complexity is big of n and the space complexity is big of n. Code will be available in the pinned comment.